Okay, so welcome to lecture 9. So in this lecture, I'm going to cover data structures in Java, arrays and objects, and I'm going to explain how you can convert objects in JavaScript into strings and strings written in JSON format back into objects. So that's what JavaScript object notation is all about, being able to easily interchange between strings and objects in JavaScript. And it's used for many sort of online applications. So we're going to start with arrays, go on to objects, and then cover JavaScript object notation. So far in this course, with JavaScript, we've looked at strings, numbers, and booleans. And these are called primitive data types. Very sort of simple, straightforward data types. So we had like var x equals cat, which is a string, or var x1 equals 34, which is like a double type thing, or a number. And then we got kind of floating point stuff, integers, and so on and so forth, and booleans as well. So these are what are called primitive data types in JavaScript. So what we're going to cover now in this section is how we can use arrays to store multiple pieces of data within a single variable. So this is here we're using JavaScript to store a single value, in this case a string in the variable cat name, but we can also create an array, which you may have come across already in Java, where we're storing multiple values within a single variable. So this is, the sort of the easiest way of creating an array in JavaScript. We just have a list of the things we want to store in the array, use it in square brackets with a comma to separate the values. You can also use this syntax in JavaScript, where we have, here's the var cat names, the variable, we say like new array, and then the sort of smooth brackets, and then we have like the list of values in commas. But obviously, why would you want to type all this when you can just write an array like that? So personally, I'd always stick to just using the square angle brackets for arrays. Now, within an array, you can mix up different types. It's not like Java, where you have to sort of specify the type of the data that's going to go in the array. Here, you can just mix up, a string, an integer, a boolean, and so on. And JavaScript won't convert it all to the same type. It'll just keep it, preserve the type of each piece of data in the array. Now, to access elements in the array, we just use this kind of index notation, which again you may have come across in other programming languages. So suppose we've got this kind of cat names here, where the square brackets have got like 4 items in the array. Now, most programming languages, array indexes start at 0, then it start at 1 for various reasons. So these are the sort of indexes that we can of the items in the array. So Ginger is at position 0, Fred is at position 1, Tom is at position 2, and Hilda is at position 3. So if we want to access, say, Tom, which is actually the third element in the array, then we have to use cat names with square brackets and then the index of Tom, which is actually 2 instead of 3, which is slightly confusing, but you'll soon get used to it. So if we want to access Tom, we just do alert, cat names 2, and then that gives us Tom. So this is from the Head First JavaScript programming book, but I think it's kind of a helpful kind of graphic to explain how an array works. So you can think of an array as a sort of as a line of buckets. Yeah, that's the right way of thinking about it. So we can imagine the array as a line of buckets. So we've got bucket 1, bucket 2, bucket 0, bucket 1, bucket 2, bucket 3, bucket 4. So we have our line of buckets, and we have a variable here which points to that line of buckets. So it's like a name for this line of buckets. And then within the buckets in JavaScript, we can chuck any old stuff we like. In this case, we're putting strings in each of the buckets, but we could also put a string here, a number here, a boolean here, and whatever kind of thing. And each of these buckets has an index value, so going from 0, 1, 2, 3, 4. So when we, so that's how we could think about an array if it's not clear already. Now, this is how we create the array, but we can also change values inside the array. So here we're creating the array with a cat string of cat names, but then we can assign, say, we can change the value in an array at position 2 just by, again, using the square brackets. So instead of accessing it in position 2, in this case, we're using the assignment operator, saying that we want marmalade to be placed at position 2 or index 2 in the array. So if we say cat names 2 equals marmalade, and we alert cat names 2, we're going to see marmalade because in this case, this is at position 2, index 2, and now we've replaced Tom with marmalade in the array. And so when we alert, we're seeing marmalade instead of Tom. So going back to this sort of bucket picture, here at position 0, 1, 2, 3, and 4, we've got vanilla, butterscotch, lavender, chocolate, and cookie dough. That's the creation of the array with this line of buckets. Now, if we want to change something in the array, then we use the assignment operator. So what we're doing is we're saying we're accessing, in this case, the index 3, which is actually the 4th position in the array, and we're saying we want to put in this bucket, this string here instead of the string that was there originally. So originally at position 3, we've got the string chocolate, and what we're saying here is that we want to place a vanilla chocolate chip in the bucket with index 3. I hope that's fairly clear. It'll become clear when you've done some examples anyway. Arrays have a property called length, which makes it easier to kind of work through them, find out how big they are, and so forth. So here again, back to the cat names here, we've got 4 elements in the array. So if we do alert cat names dot length, so cat names dot length is how we access the property of length. And in this case, we're getting 4 here. I don't know if you can read it on this video, but because it's got 4 items in the array. So I thought I'd give you a little example of arrays in practice. So suppose you're having a new baby, maybe having like quintuplets or something, right? You've got a bunch of kids coming along and you've got to figure out some names for them. Can't decide what to call it. You're having arguments, with your partner, but you like something original, right? You don't want some kind of name that's been used like John or David, some kind of lousy name like that. You want something that's a bit special, right? So here, so maybe what you decide to do is to write a simple baby name generator in JavaScript. That's how you might address the problem of naming these quintuplets who are going to be, with you anytime soon. So I'll give you a little demo, and then I'll explain it, and I'll show you how this kind of, gives you some insight into how arrays work. So here's my baby name generator. So to actually, in practice, what we do is refresh it, and it's going to give us a 4-letter name that sounds vaguely plausible. So Rama is not double. So in a real world, we want to double check that these randomly generated names don't exist already. We'd have to do some web scraping or something like that. But we're not doing that. We're just going to randomly generate names. So Rama, got Gito, Lise, Jacko, Cope, Pizu, Sehe, Site, Zeksu, Ruru. So you can see it's a bunch of fantastic names, like Zufa. What could be better for naming your child, right? So that's the baby name generator in action. And now I'm going to explain how it works. So it's all using arrays, as you can imagine. So to make this thing work, we've got one array called vowels. And this array has the A, E, I, O, U. And then we've got another array called consonants, which is like got all the consonants as you'd expect. And then we've got this bit of code. So what we're doing here, at an abstract level, what we're doing is we're picking a random index in this array, a random index in this array, a random index in this array. So we're picking 2 random indexes, 2 random vowels, and picking 2 random consonants. So I'll just explain how that's doing that. To explain how this is doing it, I need to explain this math random function and the math floor function, which you'll find useful in your games and other areas. So let's just explain the math functions first. So JavaScript has a bunch of built-in functions, lots of different ones, and one particularly useful set of functions is wrapped up in this kind of math object that allows you to perform mathematical tasks. So I haven't tried it, but I'm sure it's got cosine and logs and all this kind of stuff as well. The one you probably use the most is math.random, which generates a random number between 0 and 1. And we have math.floor, will round a number downwards to the nearest integer. If you look up the reference there, there's a bunch of other useful ones as well. So I'll just give you a little bit of demo of these 2 functions just to show you what they mean. So if you remember from the last lecture, I'm using NetBeans for a lot of these demos. NetBeans has a built-in browser here. That's the browser there. We have the output from the JavaScript here. This is like the console output. And then here I've got the script where I'm writing the actual scripts here. So let's do console.log math.random. So if we save that, we get like, 0.146 blah, blah, blah. If we refresh the web page, we're getting 0.266, we're getting 0.88, 0.513, 0.72, blah, blah, blah. So we're getting a random number between 0 and 1 generated by this math function. Now if we do math random star 10, do the same thing. In this case, I'm getting like 8.25, 3.57, 5.15, 2.94, so on and so forth. You can see because we're multiplying by 10, we're getting a random number between 0 and 10. But what we want here is to round this down so it can function as an index for our array. So we're going to do math.floor, math.random star 10. So in this case, we're generating a number between 0 and 10, and then we're rounding it down here to the nearest integer. So let's save that. And now we've got what we want, a nice neat integer. So now we've got 7, 6, 0, 5, 9. We don't want this to hit 10 because then we're going to go out of bounds on our array because the array indexes go between 0 and 9. So you can see now we've got a random number between 0 and 9. Okay, so back to our lecture. So here we are. So you can see what this is doing now. We're doing the math.random. This is between 0 and 1. We're multiplying it by the length of the vowels. So that's going to give us a random number, a sort of messy random number between 0 and the length of the vowels, which is 1, 2, 3, 4, 5, between 0 and 5. And then we're going to round that down, so we're getting a nice index for a random valid index to select a particular vowel, and the same here, a random valid index for selecting a particular consonant. So now we can build our new name. We're kind of we've got our random indexes of the vowels and the consonants. So what we do to build our name is we pick a random consonant. We're making it to uppercase just to make it look pretty. Then we're picking a random vowel, picking a random consonant, and picking a random vowel. And then we're alerting with our new generated name. So that's how this is working. And you can see how, nice, simple kind of array example, but obviously with great practical utility. Okay, so next thing I want to explain is how we can change arrays. So in Java, arrays are kind of pretty pedestrian. You kind of create this bunch of stuff, and you can't really do much with it. You need to use some kind of list or a vector or a more dynamic data structure. But JavaScript, being the beautiful language that it is, will let you play around with arrays as much as you like. So arrays are more like lists in Java. So you can add elements to an array. So we've got a fruits array here, a banana, orange, apple, and mango. We can use fruits.push, I think it may be highlighted, yeah, which will add lemon to the end of the array. So in terms of the bucket kind of metaphor, it's like adding another bucket to the line of buckets. Okay, you can add an extra storage thing. So now if we do fruits.fruits.length, we can do fruits.push. It's one way of sticking it on the end, or we can just use an index that's just one extra beyond the end of the array. So fruits.length is index position 0, 1, 2, 3, index position 4. So we're adding lemon at index position 4. We could also add it, further along, but we're just adding lemon at the next at one index along at the end of it. So this is index position 4, so we're adding in lemon up there. Fruits.push is much easier, and so I just use that if I was you. We can also remove elements from the array. We can two ways of doing this. We can use delete my array. So supposing we've got an array, mango, orange, lemon, blah, 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 grapes, avocado. We output that. Oh, this is the splicing method. So we can use delete, which basically removes the data, but at a particular index position in the array, but it doesn't actually remove the bucket, to go back to the bucket line of buckets metaphor. So this just clears the data in the bucket, but it leaves the bucket there sitting there empty. If you want to make the array kind of shuffle up and actually delete the bucket itself, it's better to use splice. So I recommend you use splice rather than messing around with delete. That's kind of pointless, I think. So we've got an array here of mango, orange, lemon, grapes, and avocado. And this is outputting the array using a for loop. So don't worry about details. So this is like array before the splicing is mango, orange, lemon, grapes, and avocado. Then splice, so are we highlighting? Yeah, so array.splice, we specify we want to remove two elements here starting at index 1. So that's index 0, that's index 1. So what the splice is going to do, with a bit of luck, is remove orange and lemon. It's going to remove two elements starting at this index here. And I think it's done that. Yep, so here we got the array before the splice, which is mango, orange, lemon, grapes, and avocado. And after the splice, we've got mango, grapes, and avocado. So you can see it's deleting the buckets and shuffling up the other buckets to fill the gap. So I'm going to demo this in Chrome Developer this time, because I think that's a better way of showing you. I can also demonstrate the debugging facilities. So let's just move this across. So here I've got a file. Well, let's create a slightly longer one. So we've got some fruits here. We're creating an array here. So oranges, I know we've got apples, oranges, grapes. You know, I don't know, feeling a bit uninspired this morning, but let's go for bananas. That'll do. Okay, so now we've got fruits, and let's just have a look at that in Chrome Developer first. So that's our baby name generator, which you don't need anymore. Now what I've got up here, here's Chrome Developer. Now if I go into sources, okay, then at the bottom here, we've got the JavaScript debugger, which if you're doing some messy, complicated, big JavaScript, you'll find the JavaScript debugger extremely useful. And what we can do within, I'm not going to show you breakpoints or any of that, I think may cover that later. What we can do here is we can add a watch expression, and watch expression means that we can look at particular pieces of data. So we can actually inspect the data within the JavaScript as the program's running, which is rather nice, right? Without having to console log it or anything like that, we can actually see the data that's inside the JavaScript. So, and we could probably step through our function here actually, come think of it. Yeah, there we go. So we can actually see the code there. We could probably have breakpoints and all the rest of it, but I'm not going to mess about with that now. But we're going to see, so here's it without the splice. We've got the fruits array that I've just created, apples, oranges, grapes, and bananas. Now if I add, go back here and do fruits.splice. Let's do 0, 3, for example. So that's going to remove 3 elements. It's going to remove apples, oranges, and grapes, and leave only bananas in the array. So that's it before the change. If I refresh it, it's left only bananas in the array. So if you're messing about with this stuff, I think you'll find the Chrome Developer tools extremely useful. I recommend you get familiar with them, particularly when you get to do more complicated JavaScript. Right, just a little bit of a warning here, really. So JavaScript arrays always use numbers as their index, 0, 1, 2, etc., etc. If you suddenly switch to using named index, then JavaScript will immediately interpret your array as an object. And after that, all array methods and properties will produce incorrect results. So you won't be able to use length or splice or any of this kind of stuff if you start using strings. Even if you use probably a number in quotation marks, it's probably going to give you problems. So always use just straight integers as your indexes to access different parts of the array, and it'll stay as an array. Otherwise, it's going to convert it into an object. So here we've got a person array. Person, this is defining it as an array, right? We're creating Nort, Joe, Nort 1, 2, adding things to the array, and then we can use person.length and person Nort and the rest of it. On the other hand, if we create an array here and we start using strings as our indexes, then immediately JavaScript's going to think it's an object, and things like person.length won't work. Now, I've already sort of covered this a little bit, but just to sort of make sure it's fully covered. Often when you've got an array, you're going to want to work through all of the elements in the array. So in the baby example, oh no, I wasn't using it in the baby example. So let's just cover it here. So here we've got fruits, my fruits array. I'm adding lemon to the fruits. And to work through the array, we just use a simple for loop. We set I equals to 0, I is less than fruits.length, I++, and then we can output, value at index I is fruits I or whatever. So, and this would be the output here. So we just use a simple for loop and use fruits.length as the to define how many times you want to work through the array, and use I as the index. So very easy. I don't think we need to go into that much. Another way of working through an array, which is appropriate in some circumstances, is to use the for each functionality in JavaScript. And in this case, we specify a function that's executed on each array element. So here again, we've got the fruits array, and here we got the for each. Now we can do it 2 different ways, right? We can do fruits.forEach. In this case, we can create our own anonymous function. So so the function doesn't have a name. We're just saying we want this function, which with this element. Element here is the element of the array that we're. So this is executed for each element of the array. The element's value is copied into this variable here, and then we can do things like console.log element. So here we're just defining this anonymous function, which will be executed for on each element of the array, and the value of that element is going to be copied into there. We can also do it this way. So we can define our own function, which is like output fruit, with an element here and console log it, and then we can do fruits.fruit for each, and then output fruit. So here we're specifying a function that we've defined globally. Here we've got a function that we're anonymous function that's sort of included in there. Okay, well I hope that gives you a rough introduction to arrays. You'll use arrays sometimes, but actually objects are far more useful in JavaScript, I find. So objects are a way of combining data and functions together into a single structure. So if you ever use struct in C++ or C, or if you've ever used a hash map, then it'll be kind of intuitively obvious what a JavaScript object is. So objects can also contain functions, and we can use JavaScript objects in an object-oriented way, which is similar to object-oriented programming in other languages. So so in a later lecture, I'm going to go into all the JavaScript object-oriented stuff in much more detail, but I'll touch on it a little bit here. Here I'm going to really focus on objects as data structures. And an object consists of one or more name-value pairs, and we just create an object in the following way. So here we have var person, so this is like the name of the object, the sort of variable that holds the object. And then we've got a series of key-value pairs. So the key here is name, the value John, key, value, key, and value. So the first thing for objects is, instead of the square brackets which you use for arrays, with objects you have these kind of curly brackets. Then we have the set of key-value pairs. So the key is always some kind of string that's used to identify the key. And then we have the colon to separate the key name from the value. And then we have the value, which can be a string, can be a number. As I'll explain later, it can also be another object or an array, and so on and so forth. And then each of these key value pairs is separated by a comma. That's all there is to it. Dead easy. Now, to access the properties of an object, the most common way of doing this is to just use a dot. So here we have our person with a set of key value pairs of notes. So the keys are name, age, and alive. So if we want to access name, we just have person.name. If we want to access the age, person.age, person.alive. So in this case, we're outputting, the sort of values within the object, plus a break to separate it nicely. So we get John, which is the person's name. We get 50, which is the person's age, this value here. And then we got true, which is whether John's alive or not. We can change properties in the same way as any other variable. All we do is we simply access them. So here we've got a person whose name is John, whose age is 50, who's alive. And we can change the age here by accessing the property. So here we're accessing person.age and setting it to 38 instead of 50. So now when we output the object, we're getting John 38 true instead of John 50 true. We can also add properties to an object. JavaScript has that wonderful flexibility to it, which obviously you can hang yourself with, but at the same time, can be great in some contexts. So here we can just create an empty object, right? And then we can just assign properties to that object, person.name, person.age, person.alive, and then when we output it, we get the same, John, person, alive, whatever. So empty object, and then we can just dynamically add properties to it, and we can keep adding properties as much as we like, in a sort of dynamical way. Another alternative syntax is to use these kind of square brackets. Now, most of the time, you're not going to bother, right? Because it's an extra 1, 2, 3, 4. It's an extra 3 characters you've got to type each time. So most of the time, you're not going to use this. But this is useful if you're kind of dynamically accessing objects, and you've got a kind of string as a name for the key. If you've got a string as a key, then you might need to use this kind of square bracket notation to access the object. All right, well, let's have a little demo. So I think we'll use NetBeans this time. So just show you, just simple example. So here we have var my obj equals, let's stick with the fruit, right? Can't go wrong. My cat, right? Right, so we use curly brackets, and then, I think we just use name, Fred, age 17, it's a very old cat, this, and Let's do breed. Let's just do breed Siamese, let's say. So there we have our cat with the curly brackets, and then we can do console log my cat dot name. And if we save that, it's going to output Fred, right? Because that's the name of the cat. So we're just using the dot notation to access name of the cat. And then we can change the name of the cat. My cat dot name equals Angus, let's say. And then we can do console dot log my cat dot name again. So save that. So we're accessing the property of the object here using dot notation. We're setting it to Angus instead of Fred. So first it outputs Fred, because that's the original name, and then we change that to Angus. So easy peasy. So had a rather complicated example in the previous lecture about this whole thing about passing arguments by value, I think it was. When we're passing strings, numbers, and booleans to a function, their values are kind of copied into the function. So when you manipulate things in a function, manipulate strings, objects, and booleans that are passed in as arguments, you don't change their values outside of the function. So each argument is copied into its corresponding parameter. So any changes to a parameter's value within the function only affects the parameter, not the original variable that you pass to the function. This is sort of the thing to remember with strings, numbers, and booleans. Whatever happens in the function stays in the function, right? It's a paraphrase of what happens in Vegas, right? So here we had a little example. Okay, I think I'll stick to this. Some kind of slide mess up there. So we had this increased number example. So we had a function increased number. We're passing in a parameter number, and this function is increasing this number by 1. So when you call this function, so we've got my number, which we're setting equal to 10. We're passing this number into the function. It's increasing the number, but actually when you write out the number here, it has no effect, right? It's still equal to 10. So the number stays 10, even though I've called a function to increase it. And the reason that doesn't increase it is because the value of my number variable is copied into here, and it's only increasing the copy. It's not increasing this variable here, okay? That's what it means by what happens in the function stays in the function, because any changes to this don't affect this variable here. Objects and arrays work differently, and that's what you want them to do. In this case, the object or array is passed into the function. It's not a copy in the case of an object or an array. So the function can change an object or an array. So whatever happens in the function does not stay in the function, okay? And this is called passed by reference. I think the other one's passed by value, and this is passed by reference. So here's a little example. So here we've got a function called kill, and we're passing in a person object here. And we're setting the status of the alive state, the value, we're accessing the key alive and setting it to false in this case. So we've got an object here, John, whose name is John, whose age is 50, and he has got a Boolean value, whatever. So the key alive has a Boolean value of true. Now we're going to first, we output the alive status of John, whether he's alive or not, and in this case the alive status is true. Then we call the function kill. In this case we're passing the object John to this function kill, and in this case it's changing the object, and we're passing the object itself into here, so we're actually changing this object here. We're not just changing a copy of it. And so finally at the end, when we output the new status of John, it turns out that John's alive status is false. So with with arrays and objects, when you pass them into a function, whatever happens in the function does not stay in the function. It changes the object or changes the array itself. JavaScript objects can rapidly become complicated. The reason they become complicated is because the values of properties aren't just primitive data types. They can also be objects or arrays themselves, and these objects and arrays can contain further objects and arrays. So you can get enormously complicated data structures, which is good because it's flexible, but it's bad because it can get a bit messy. So let's suppose we've got 3 objects here. We've got John, Julie, and Jim, right? Same stuff we've covered a million times now. Now we can have a team which consists of these three objects, which consists of an array of these three objects. So this is an array, same as, array of objects in this case. We've got John, Julie, and Jim. So if we do document write team.length, then that's an array, so that should be, that'll be like 3, right? That's the length of it. But we can also access team2, which is Jim.age. So here we're accessing the second element, the element in the array with index 2, which is the third element in the array. And this is an object, so we can use the dot to access a property of Jim. In this case, is age. So team2 accesses Jim, and .age accesses 45 here. We could also have written this thing completely in a single line of code. So here we have var team. Again, it's the array objects, but instead of creating John, Julie, and Jim separately as objects and then putting them in an array, we can actually create them all at the same time. So here we have a team, square brackets because it's an array, and then here we're putting the objects actually inside the array as we're creating it. So we're creating the first object here, the second object here, third object here, followed by the closing of the array. And so it's exactly the same effect, but obviously it's more complicated. When you look at it, it's obviously a little bit more complicated to understand. We can also have objects within objects. So here we have, again, two objects here, and then we have a team where we have the key person and the value John. So this person 1 is pointing to this object here, and this person 2 is pointing to this object here. So again, we can have team, which is this object here, person 1. So in this case, it's pointing to John, and then .name, which is accessing this key here. So this is why it gets a little complicated, because we've got the team object is accessing the person 1 within the team, which is accessing the name within the object that person 1 is pointing to. And the same one with team.person2.age is pointing to this part of the data here. And in a similar way to the array example, we can actually create this all at once. We can have like team, and then we have person 1 is the key, and then the value, instead of just creating the object separately, we can just point it to another object here. So the key here is the person 1, and the value is another object that we're defining there. And then we have another key here pointing to another object here. And so it's the same effect. We have team.person1.name, and that's getting us to this piece of data here. And team.person2.age is getting us to this bit of data here. And when we come to JSON, which I'm going to talk about in the next section, you're going to see a lot of this kind of stuff. And with a little bit of practice, it'll become more intuitive and obvious. And with MongoDB, you're also going to see a lot of this kind of stuff. So, it's good to get used to it fairly soon, I'd say. So yeah, these are the two objects pointing at. And then, just to finish it off, we can have arrays within objects. So in this case, you've got a team, which is pointing to an object here. This is an object, curly braces. And the team has a name, which is like 5-a-side, whatever. And then it's got another key players, and the key players is pointing to an array in this case. So if we do team.name, that's accessing this piece of data. And we can also then team.players is accessing this key, which points to an array. So we can do team.players.naught will give us John. Team.players.4 will be 0, 1, 2, 3, 4 will be Janet in this case. Okay, well, let's do a quick demo. So there we go. So my cats, let's say. So let's create an array of. So that's an array. My cats, standard array, yeah. But instead of having, objects, instead of having, just names or something, let's create an array of objects. So we have name, Ginger, age 20. Let's have some really ancient cats. Now, we've created one object there. Now, since we created one object and we want two objects, we're going to put a comma after that. And then we're going to create another cat here. Okay, so let's create name. Let's go back to Angus. It's a good name for a cat, Angus, I think. And then age, let's have a younger cat, 3. And then close that. But in this case, we don't have a comma because it's going to be the end of the array. And just for fun, let's put it in Chrome Debugger and see what you see. In fact, let's not. So let's just do let's just output something. So we could do. So in this case, it's an array. So console log my cats 1. So I'm going to access Angus here, and a property of Angus, which would be age, let's say. And then we'll save that. And in this case, it's 3. And if we do my cat's 0, I'm going to be accessing Ginger. It doesn't look stupid there. Accessing Ginger, which is 0, dot age, in this case 20, right? Which is correct. Now, I don't have to create an array here. I could do this in a different way. I could create a set of keys and values instead. So let me move this out of the way a little bit. Okay, so I can do cat1 is my key, and then the value here can be another object which contains the details of cat1, and then I could have cat2, which is another key pointing to another set of data containing details about cat2, and then that has to be curly brackets. So in this case, I'm creating an object, and the object has 2 keys. One key is cat1, which is pointing to this data structure, and the other object inside the object is cat2. And in this case, I do something like cat1.age. Okay, I've got some kind of error there. Oh yeah, my cats. That's it. My cats. I haven't got the object, access the object yet, right? My cats dot cat1 dot age works, right? So in this case, it's my cats, this object here, cat1, this key of this inside the object, and then age, the object inside the object, has a property called age. And I could do the same with cat2 and all the rest of it. So far, in all these examples, I've just been talking about JavaScript objects as a way of storing data. Objects can also contain functions, as I'm going to cover in the lecture on advanced JavaScript. Functions really work just the same way as other variables. And when a function is included inside an object, it's called a method. This is sort of object-oriented terminology, and a collection of properties and methods used in many programming languages. So in Java, you've probably come across this already. You have like some variables or inside an object, and then you've got some methods, and the methods typically manipulate some of the variables, and you can use this to model things in the real world. So that's the beauty of object-oriented programming. You have this object, and you can change the behavior, and you can control the behavior of this object by invoking methods on it to model, a hurricane or model a ship or whatever you like, right? And this is called object-oriented programming. So here's an object with a function. So here we have var person, that's the name of the object, right? It's got a key, name, value John. And here we've got another key, but in this case, this key is pointing to a function instead of pointing to a piece of data. So in this case, the function's just doing alert hello there. So it's the same syntax, except it's an anonymous function, it doesn't have a name. It has a name, say hello in this case, right? But this is sort of defined as the value associated with the key say hello. And if we want to invoke that function, we just do person.sayhello, and to tell JavaScript that it's a function we want to invoke, we use these kind of like smooth braces. So if we do person.sayhello, it's going to execute the code here and output hello there. Now functions inside an object can access other properties of the object, but to make that work we have to use the this keyword, otherwise it's going to think it's a global variable or something like that. So we've got a person one here pointing to this kind of data structure with this function, so on and so forth. If this piece of code here wants to access this name here, we have to use this.name, and that's telling JavaScript or telling the browser that we want to access a variable with the called name inside the same object that this function is defined inside. So if we do say hello, so in this case it's going to say hello, and the same is true here. We've got a second person with a second function. In this case, this.name refers to Judith, whereas this.name here refers to this one here, John. So if we execute those, we get hello David, I'm John when this runs, and hello David, I'm Judith. Otherwise, it's going to create an error if you don't have the this.name thing. Okay, so let's do a little quick demo of that. So let's create a, let's stick to cats. Var cat equals, so we've got an object here, and we're going to give it a variable, so stick to names. So the name of the cat is Freddy, and we're going to have a function. This is going to be poke, let's say. So that's just standard key, same as anything, and then we have a function, console log, console log this dot name plus says meow. Okay, it's code name Freddy. Okay, so just check this works. So then we do cat.poke. Great. So it's working. So we're creating a little object here called cat. Cat has two properties, like a name, Freddy, and it has this poke. Poke in this case is pointing to a function. And what the function does is just outputs the name of the cat and says meow. In this case, we have to access this.name. This.name means we're accessing Freddy here. And then if we do cat.poke, it's going to call this function and output Freddy says meow. So let's just try without the this.name. So it probably won't work, or it'll complain about something or other. Oh yeah, well it can't find it, right? And if we had like var name equals George, it may well find it there. Yeah, there we go. So it's looking for, if we don't have this.name, it's looking for a kind of globally defined variable called name, which it can't find unless I create one there called George. So in this case, it's going to say George says meow because it's looking here. Whereas if I say this.name, then it says Freddy says meow because it's accessing the name inside the same object that the function's been called in, that the function's defined in. So in general, it can be very helpful to represent real-world objects with JavaScript objects. So we add properties that represent the properties of the objects and functions that change the objects in appropriate ways. So, you know, I think do I have an example? Yeah, in your coursework, for example, if you're doing a card game in JavaScript as part of coursework 1, then maybe you've got objects representing the cards in the pack, and then you can have like a deal function and a shuffle function that that do appropriate operations on the cards. If you want to do objects properly, you need to use constructors, maybe prototypes, and I'm going to be covering that later in the course. I will see chapter 12 of Head First JavaScript Programming Book. So last thing I want to cover in this lecture is JavaScript object notation. So I've explained how you create objects in JavaScript, done a lot of that now. This is also a very popular way of describing exchanging data. So, you know, when I started in web development, you know, XML was all the rage, right? They even made HTML into an XML compatible format, which was a bit nuts. So XML used to be all the rage, but now we have JavaScript object notation, which is a much more compact, efficient way of exchanging data, and has the further advantage that it's very easy to convert JavaScript objects into JavaScript object notation and JavaScript object notation back into JavaScript objects. So if you're if you're communicating between a web browser and a server, it's a very nice way of exchanging data and perfect for coursework 3, as we'll come to. So to make this work, we have JavaScript. We have to convert the JavaScript object into a string, and to do this, we put the property names in double quotation marks, and we leave the property values untouched, and then we need quotation mark at the beginning and the end of the string. So here's our object definition in JavaScript, and the equivalent in this JSON representation of this object looks like this. So you can see that name has become like name with a double with quotation marks around it. All of the keys have double quotation around them, and then we have a single quotation mark the beginning and end of the string. And the values themselves, so you can see John stays the same because it's a string anyway, whereas 50 stays the same and true stays the same. So we don't change any of these. It's merely the keys being converted into adding quotation marks to them. Why on earth we had to do that, I have no idea, but that's how it is. And JavaScript has very nice methods for converting an object into JSON and a JSON object back into a JavaScript object. A JSON string back into a JavaScript object. So suppose we've got a string here in JSON format. If we want to convert that into an object that we can actually access the properties on, then we need to do JSON.parse on the string. So that will take this string as itself is just a string. JavaScript treats it just as a string. But if we want to convert that into an object, we do JSON.parse person string, and that'll give us person, and then we can output person.alive, for example. We can then access its properties. If we do person_string.alive, it's going to create an error because this is just a string. We need to convert it into a JavaScript object before we can use it as a JavaScript object. We can also go the other way. We can convert JavaScript objects into JSON strings. So suppose we've got an object here, and we want to convert that into a JSON string. We call JSON.stringify. So to convert strings into JavaScript objects, we use JSON.parse. To convert JavaScript objects into JSON strings, we use JSON.stringify. So now if we do document write person string, we're going to get this here, which is like a string representation of the object. So very useful for outputting objects for debugging, and very useful if you want to communicate for communicating between server, and very useful for storing objects in HTML local storage, as we'll come to. So let's have a little play with that. All right, so yeah, I'm going to bother that. Let's do start from fresh, right? Var cat equals name. Stick to George. Age 12. Alive. False. George is deceased, right? So we've got a dead cat, and let's console. Now, if we do console.log cat, it's going to give us some kind of unpleasant error, probably. Yeah, it's just saying object. Oh, wait a minute, we've got cat.poke. That's an error. So if we do console.cat, it just outputs object because it's not, something can really output very effectively. Now, if you want to convert that into a string, a JSON string, var cat string equals JSON.stringify cat. So that's going to convert cat into a cat string, and we can output cat string instead. And now we can see it's taken this cat object and converted it into JSON format because we've got the double quotation marks around each of the keys, and as I said, the values themselves are unchanged. So now we've got a cat string. Now if we want to try console.log cat string dot age, should get an error. Yeah, it's undefined. So cat string is just a string because it's just this. And if we try and do .age on there, age doesn't exist in there. It's not an object. It's undefined. On the other hand, if we do var new cat obj equals JSON.parse cat string. So now we're converting our cat string back into an object, and we can do that should work, right? So we've got a cat string, which is the stringified version of the cat, which is this. We're converting we're converting that back into an object, a new object here. And this new object, we can access the property age because we converted it back into a JavaScript object. So for coursework 1, it's a requirement that you store the user data and scores in JSON format. So one way of doing this is to create an array, call it users, let's say, and then each time someone registers, you create a JavaScript object, with the details, like the name, email address, the top score of the person. This could be initialized to 0 initially, and we could just add each of the new people that registers to the array using push. So we're adding an object representing the new user at the end of the array here. And then to store it, we can convert this array users into a string, and I'll show you in a later lecture how you can actually store that in local storage. So we can just convert users into a string. That'll give us a string here we can stick into local storage. And then when we want to retrieve it from local storage, all we have to do is JSON.parse, and that'll convert it into an object, and then we can add more users or access properties of the users, such as the top score and so on and so forth. So yeah, once we converted it back into an object, we can then push like a new user at the end of it, or we can modify the top score and then store it again in the local storage. You'll also be using MongoDB database next term, and this uses a storage format based on JSON. I told you JSON was good, right? So there are MongoDBs entirely based on JSON, even the queries are JSON. So you're doing a lot of JSON next term, which is why I'm introducing it this term and getting you to having a bit of practice with it using the local storage. In both coursework 2 and coursework 3, you're going to be using Ajax to communicate between JavaScript in the browser and PHP on the server. So actually in coursework 2, it's the case that you're going to be using Ajax to communicate with PHP. In coursework 3, you're going to be using JavaScript to communicate with JavaScript running on the server. But anyway, both of them are going to be using Ajax. And JSON is an efficient way of wrapping up data that's exchanged between client and server. So if you think about it, we can just wrap, this is just a string, and we can send that string to the server. If the server is also running JavaScript, then the JavaScript can convert that back into an object and do whatever it likes with it, and then send it back again, and then client can again convert it back to an object, and it's a very nice way of communicating between client and server. So a lot of this stuff, all of this can be found here at First JavaScript Programming chapters 4 and 5. So again, as I mentioned earlier, if you want to get good at this stuff, you could do a lot worse than working through these chapters, working through the examples. It's very nicely explained, and you can read this in electronic format online through the Middlesex Library Catalog. As I mentioned before, I like John Duckett's books. I haven't read this one, but if it's as good as the HTML and CSS one, then it's going to be pretty good. So you might also, if you're more sort of visual or design-oriented, you might find this a helpful approach. Okay, so this lecture, I've introduced you to JavaScript arrays and objects. Also introduced you to JavaScript object notation, which is used to exchange and store data. So next lecture, we're going to look at the document object model, event handling, and forms.